Okay. Okay, I should be live. Should be live. And, I apologize, everybody, for not being able to do Tech Thursdays yesterday. But there was a bunch of stuff that I had to do this past week. Like, a ton of things that completely unrelated to YouTube. So I wasn't able to do the overclocking video for this CPU over here, the D2. I still need to do that, so I'm going to make a priority of working on that next. But let's just say I finished all the stuff that I need to do, so now I'm finally able to dedicate time again to working on stuff like the overclocking video, because this week was just crazy busy. Yeah, this week was crazy busy. Last week was what I call the Linux crazy week. It was the week of the Linux, although this week I continued to use Linux. So even though I wasn't really able to do anything for the channel, I was continuing to use this framework laptop 16 as my daily driver. I've been using this laptop literally all week and all of last week. And this has become my main laptop. I'm getting more and more used to Linux and the terminal and all this stuff to the point where, I don't know, man, I kind of think I might end up switching to Linux permanently at some point. But I am currently back on the Windows computer. I have not fired up this computer in what feels like forever. And the moment I turned it on, immediately there's like tons of Windows updates that I have to install, browser updates, like everything. The Windows Defender wants to do an antivirus scan in the background, and all this stuff starts running, and the fans on the computer start going because the CPU is being hit with all these background tasks. So, you know, the typical Windows experience when you've been gone from the PC for a while. It's just like, hey man, wherever you've been, there's like all these updates, it's like 1,000 updates. So, the last time I used this computer, I don't even remember. I think it was when we were live streaming Saros. And when was that? That was 12 days ago. I can't believe it's been almost 2 weeks. It's been almost 2 weeks since I've used this Windows computer. This is not the same computer that I use for Tech Thursdays, by the way. For those of you that wonder what I use for Tech Thursdays, I've been using Strix Halo for Tech Thursdays now for the last 2 or 3 episodes. So, because I noticed the thumbnail for Tech Thursdays has basically been the same thumbnail for the last 3 episodes. Now, obviously, this week doesn't count because there was no Tech Thursdays. But for the last 3 episodes, I've been streaming on Strix Halo. So, that's probably why, because I don't have access to all my, like, my video editing and all that stuff. It's not installed on there right now. So, the Microsoft Windows 11 has this here. What? The Microsoft Windows 11 has a certification requirement. Wait, what? Do you mean Windows 10 for extended support? As far as I know, there's nothing you have to do specific for Windows 11. As far as I know, it's basically the same thing. But so one of the things I had to do this week, which I was working on in the background while trying to do all this other stuff, I had to renew a certain certification. I had to basically do my certification exam today. And I basically had to study for the past 3 weeks. And this week, in addition to like work and all this other stuff that was going on simultaneously, I had to really study. So unfortunately, that's the reason why I wasn't able. I planned to do Tech Thursdays yesterday, but it got to the point where I realized I'm gonna just have to sit down here and like study like all evening. So I basically studied yesterday from like sun up all the way until like 3 to 3:30 in the morning. Like 3 a.m. Friday morning. So I was thinking, man, could I do Tech Thursdays for like 1 hour, 2 hours? And when I think about it, I think I made the right choice, because if I did Tech Thursdays, I feel like I would have not been able to sleep at all, and I don't think I would have performed that well on the exam. So, but I did manage to pass, because it's funny you bring up certification, because that's exactly what I had to do today. I had to take the test, and I did pass the test. And toward the end of the test, like when it was down to the last 30 minutes, 40 to 30 minutes remaining on the exam, I was thinking, man, this just, I don't know, this is starting to look pretty bad, because I was starting to run out of time. I mean, not run out of time. I finished with like 12 minutes left, which is a decent amount of time. But, man, I had to go to the bathroom really bad. Like, I had to pee like really, really bad within the last hour of the test. And I also was like sleep deprived, and I was starting to feel like really nauseous toward the end. It was just not good, man. It was not good. I had to take the test. I had to take the certification exam, you know. And you know, the thing about these sort of exams is like you get toward the end, and then you start getting hit with what you don't know if the questions are experimental questions, meaning they don't affect your actual score, or if they're legitimate questions, or if they're actually like worth a lot of point questions. So that was nerve-wracking, because you start getting all these weird things. You start getting these weird questions that it's like, is this real? Like, are they like trying to pull a fast one on me or something? Like, what is this? All the while, you're getting more fatigued, because it's extending the time that it takes to have to process the question, to think through the answers. And on top of that, I had to go to the bathroom so bad, man. It was so bad. I made it a habit to not like drink anything like 30 to 40 minutes before the test. And literally in that last hour, I had to go, and I was like, man, if I get up to go use the restroom, the clock is ticking. I'm not going to get any of this time back. So it's either I hold it in and just deal with it and just do the test, but at the same time, don't like screw up and mess up because, you know, like I can't concentrate. But it's, I don't know. I'm just glad that I passed, man. All I care about is that I passed. It was so nerve-wracking in the last 20 minutes. Last 20 to 30 minutes, I kept thinking, oh man, these questions, this doesn't seem right. Like, I feel like I'm second-guessing myself too much. This is, I feel unprepared for this. It's like, oh man, I skipped Tech Thursdays for this? Like, what? But then I ended up passing, so I was like, okay, fine, I guess it was worth it. Oh man, what a crazy week. Like, I was supposed to do the overclocking on the D2, wasn't able to do that because of this. I was supposed to do something with Linux, I wasn't able to get to that, although Linux did come in handy, the Linux PC. I literally, guys, I use this laptop. The Framework 16 is literally the laptop that I used for studying for the test. I did all the studying on Linux. Literally all Linux. All in on Linux, with the one exception being VMware. VMware Workstation was like the other thing that I had to use. And you know what I had to do with VMware Workstation? Threadripper, man. Threadripper and a ton of RAM. You gotta have Threadripper, you have to have RAM, you have to have cores. We're talking hypervisors. We're talking all the sort of things that the certification is talking about. Did you do the Red Hat? No, I'm thinking about it though. I'm thinking about Red Hat, man. Especially since Fedora has become my daily driver. Red Hat certification sounds pretty good. They often do those questions to catch if you use a leaked practice test. What, you mean the fake? You mean like the weird experimental questions? Well, you know, some of the questions are like, the questions that I don't like are, because they're so controversial, are the questions where it's literally hard facts. Like, you either know it or you don't, or you may have known it once upon a time and you forgot. You know what I mean? Like, I can't say any of the questions, but you know what I'm talking about. Like, some hard fact of like, XYZ uses blank. And then it's like, they give you A, this, B, that, C, this, D, that, E, whatever. You know what I'm saying? Like, those type of questions where it's like, okay, you either know the hard fact of what it uses or you don't. And then it's like, they always word it in such a weird roundabout way. If it's one of those, what I call $20 word questions where they've got like a bunch, it's like this boatload of big word vocabulary, like all like A is blah blah blah, inter-establishmentarianism, B is blah blah blah, unitary, whatever, blah, C is utilitarian, D is, you know, like those type of questions, man. It's all like, those are just definition ones. CompTIA and AWS are some examples that use trap questions to where you get a number of them right. It flags your exam. I don't know. All I know is this test was brand new. And it well, okay, it was not brand new. It was new in the sense that they changed the exam recently. They redid the whole curriculum as of, I think, like late March. And they front loaded it with a whole bunch of like simulation things that you have to do. Like performance-based what do they call it? Performance-based questions or performance-based tasks that you have to do, and there was like 6 of them, all one after another, all front loaded at the very beginning of the test, and then after you get past all of those, then the rest of the exam is like a whole bunch of multiple choice questions and matching and, you know, those type of things, or like fill in the blank type things where you drag over the what the correct answer is supposed to be. You know, the thing that surprised me, Python, man. Python, oh my goodness, Python. Dude, like the amount of like coding, JSON, Python, like, oh my goodness. It's funny, we were talking about this on Tech Thursdays last week briefly. I think we did. Did we talk about the automation platforms? I think we did. Hold on, let me see. I am legit exhausted right now, though. I only slept probably like, I don't know, like 3 hours. Because I went to bed at like 4 a.m. in the morning, and then I had to get up. And then when I got up in the morning, then I immediately went back and started drilling again for the exam. Like, dude, and I was dreaming of like the concepts. Because I was remembering like the mnemonics and like, you know, like 4-letter acronyms to remember, like the order of different things, that kind of stuff. Oh man. Hold on, where's Paint? Where's Paint? I forget that I'm on Windows. I keep thinking, okay, yeah, we're on Windows, okay. But you know what we talked about on Tech Thursdays last time? Do you guys remember, who here is familiar with this? Does anybody watching this stream right now? This is weird because this is like a gamer live stream and we're talking about this. Nowhere else on the internet, I'm telling you. Okay, has anybody heard of this thing? Ansible? Does anybody know what this is? If you know what this is, congratulations. What about this? Or this? Or this? I think it's one word. I think it's one word. It might be 2 words. I can't remember anymore. My brain is too fried. And there's another one which I know nothing about. I know very little about this last one. I don't know if this one's popular anymore. You know, you guys remember this stuff? Who here knows about these things?
We missed you on Tech Thursday yesterday. Hopefully we can cover the news that FSR 4.1 is coming to 7000 series and could mean FSR 4.1 for Steam Machine.
Yeah. Yeah, and I missed you guys too. And you know what? I see the super chat, but why did it not? Did it show up on the screen? I didn't see it on the screen. I see it in the chat. I don't see it on the screen. Hold on. It should have shown up. Oh no, it did because it played. But was it visual? Did you guys see it? I heard it. Did it play? Did you guys see the super chat on the screen? My brain is like not working properly right now because I'm so exhausted. So I don't know if did it play? Could somebody confirm if they saw the super chat on the screen? Did anybody? I mean, I heard it. Oh, okay, you saw it. Okay, okay. So then it's there. For some reason, I'm probably only like half conscious right now. so that's why I didn't notice. I heard it. I heard the super chat, but I don't know. Appreciate the super chat, by the way. But yeah, I missed you guys too. But man, I did not realize how many things I had to study in the last like 2 weeks. And when it got into the final 3 to 4 days, I could feel the pressure. And I was like, oh man, okay, I have to literally cram like it's finals week in college. You know what I'm saying? It was one of those. I had to do one of those. It's just like... So anyway, this is one example of what I had to deal with today. These things. Ansible, Puppet, Chef, and SaltStack. Terraform, thankfully, I did not have to bother with Terraform. Oh my goodness, if I had to learn a 5th one, oh my god, I don't know. Like, my brain is about to, like, drop all the knowledge out of it. It's like, when I went to go take the exam, I was, like ready to explode with all the knowledge. It's like, can we get this over with? And now it's like, okay, now it's just starting to, like, fall out of my head. You know, so anyway, these things on the screen here are automation. They're automation platforms that can also be used for scale up. So one of the real popular ones in the most recent years is Ansible. So this is one that I think a lot of people that have either been in industry for, you know, a decade or so, or maybe a little bit longer, or even if you're early in career, you're going to encounter this at some point. These other guys, Puppet, Chef, and SaltStack, I don't remember the year that SaltStack might be either around the same age as Ansible, or might be a little bit newer, might be a little bit older. I forget exactly the year on SaltStack. I know, like, Ansible has been around since, like, 2012. Just FYI, to give people a time frame on this. Puppet is the OG, man. Puppet is 2005. This is like the year of the Xbox 360. You know what I'm saying? That's like way old school. Chef, I think, is 2009, and I don't remember the other two. I can't remember right now. My brain is like all fragmented. I need to defrag, but it's like all messed up. Ansible was acquired by Red Hat. Yeah, Ansible. Yeah. Ansible was acquired by Red Hat. Ansible is the one that you'll hear a lot about in a lot of things, like in the Linux ecosystem world. You hear about that when you talk about Linux servers. These older ones are interesting. So Ansible is something called procedural. Procedural, meaning it gives you a step-by-step, like you're gonna go from point A to point B. Think of it like Google Maps. Like, you need to figure out how you need directions on how to get somewhere. Ansible tells you the step-by-step. It's like step 1, do this, step 2, do that, etc. You know, like, that's basically how Ansible works. It's procedural, so it's step by step. These other ones, Puppet is actually quite interesting. The more I delve into Puppet, the more I actually kind of like the OG stuff like this, because this one is not procedural. This one is called declarative. Declarative. So this one, it doesn't really focus too much on the actual steps to go from point A to point B. It basically tells you the end state, and you basically figure out how to make that happen, if that makes sense. So it's a declarative in the sense that it declares what the end state should be, or the end goal should be, and then it's basically up to the people doing the implementation to figure out the rest, if that makes sense. That probably just confused everybody. And then Chef is also procedural. Salt Stack, I think, is declarative. I don't know what Terraform is. And then procedural. So this one uses like playbooks, which have the procedures. Chef is similar. It uses cookbooks and recipes. I think we can't type recipe. Oh boy, there's an I somewhere. I before E, except after C. Recipes. That doesn't look right to me. I can't spell. My brain's too tired. So anyway, let's just say cookbooks, even though they do have recipes. So basically, this one is Chef, Ansible, and then Puppet uses something called Manifest. Puppet sounds really cool. Like, it sounds really weird. It's like, okay, the other thing too is this one, like, has the Puppet Master. It sounds like some kind of thing out of, like, Lies of P. It's like some kind of weird video game terminology. You know what I'm saying? Like, what?
Playing Forza Horizon 6 on my 5120 by 1440 G9 OLED. 1000 nits peak brightness is such a huge downgrade, but for racing games I like this form factor.
Wait, 1000 nits is not good enough? I don't think I have a single display that can get to 1000 nits. I think the OLED that I have can get close with the HDR. I don't even know if this can do 1000 nits. Forza Horizon 6 came out this month. That's right. I almost completely forgot. That game, there was another game that came out recently. Didn't the 007 game also come out? The James Bond game? Isn't that also out? Like Forza Horizon on 5120 by 1440. That's a widescreen. So you're playing this like, is it like a racing simulator setup? Are you using it like in a racing simulator? Since it's widescreen like that? You're playing Forza Horizon 6 right now? Okay. What wheel do you use? 007 is on GeForce. Oh, wait, you received a free copy from GeForce Now? This was something that I had to do today, though. Like, just to give an example. Like, not Terraform, except everything but Terraform. And there was a lot of other stuff on there too. Like, I'm not gonna go into any super details. But I can talk like general things. So I had to do this thing where, well, we're not gonna talk about the specifics, but if you guys are familiar with the concept of the ETR, the ITR, the MS, the MR, these things, or also known as like the XTR. This can also be an XTR. This is basically a control plane, in control plane, in control plane, control plane nodes. These things were also something that I had to deal with today. It's called Moza. It is a direct drive. Oh, that okay. You know what? I think I may have seen one of those, something similar to the Moza, last year. I saw one, I think at a Micro Center. I think Micro Center was showing off like a sim racer, like a actual. The chair, the wheel was there with the pedals. I feel like I've seen something similar. I don't think it was Moza, but I've heard of Moza. Fanatic and Moza. It might have been Moza. I remember hearing Moza, but I don't know if that's the actual one that I saw in person. But yeah. I remember seeing it at like Micro Center a year ago. It was like last summer. They had a demo set up. Yeah, that's pretty cool. I haven't played sim racers like that since Gran Turismo. Was it Gran Turismo 5? Gran Turismo 4 or 3? The one that was on the one that was Gran Turismo Prologue on PS3 forever. It was like in Prologue for like several years, and then it finally went to, I forgot which one it was. It was PS3 era though. Like I haven't played a proper racing simulator since the PS3 era. The last games that I played with a wheel, and the wheel that I still have somewhere in storage, it's the Logitech GT. It was the one for the PS3. It was the one for like Gran Turismo on PS3. I played like Need for Speed Shift, I believe, and some other game on PS3. 4,000 nits. How, like, I can't even comprehend how bright that is. As someone who literally uses laptops on a regular basis at like 0% brightness, like I can't even comprehend 4,000 brightness. I literally can't. I don't know. I don't even know what that's like. What will be the nits of like looking at the sun? If the sun's like 20,000 nits, is that what, like, hold on, maybe I can find the answer. How many nits is the sun? Oh my goodness. Okay, never mind. Never mind. This AI says the sun at noon emits approximately 1.6 billion nits. So, okay, so 4,000 nits isn't that bright. But still. $75-inch TV. $4,000 nits is for specular lighting or highlights. Forza Horizon 6. Are you guys playing? So, does that game have... How many cars are in that game? Can you use regular cars? Or is it all just like sports cars and supercars and exotics? You know what I'm saying? Do they have like normal cars that are turned, or do they have like the rally cars, or is it not that type of game? Keep in mind, I haven't played a simulator or simu racing game since the PS3 era. A lot of there's trucks in the game. Wait, there's trucks? Like, are there 18-wheeler semis? Can you drive a semi in the game? I mean, because it's like, I don't want to drive no boring, like, Tacoma, you know what I'm saying? Like, where's the 18-wheelers? S99 Asia's the winner this year, if you can accept the ugly bezel design. Oh, the OLED. Yeah, I had to do this stuff. There was like Ansible, there was Puppet, there was Chef, there was Salt Stack, there was these guys. This is known as Lisp. There was some other thing that people here might not know about called VXLAN. There was the concept of underlay, overlay, underlay, layer 3, layer 3. Strangely enough, layer 3, yeah. These are sort of the things that I had to deal with today. Or basically all for the last like 2 weeks. But this week, it just got more and more like amplified. We already talked about Ansible, Puppet, Chef, Salt Stack. There was also VBond, vManage, vSmart, vEdge. What else? There was I'm trying to remember what else there was on there. There was like so much stuff, man. It was just too much stuff. It's just too much stuff. I keep thinking, you know how I memorized these guys? I don't know if you guys ever played Tekken Tag Tournament on PS2. Tekken Tag Tournament, no, Tekken Tag, yeah, the first Tekken Tag Tournament. Tekken Tag Tournament, the launch game on PS2. There's a song in the game. I could never understand what the lyrics were because the song was so distorted. But like when I think of the song, it's like VBond, vManage, vSmart, vEdge. It's like I just kept like thinking, remembering these names because of the Tekken. I would just sing the Tekken song in my head. I'll play the Tekken song in my head with these lyrics: VBond, vManage, vSmart, vEdge. It's like I would just, oh, okay, I can remember, you know, like because of a video game. I mean, even though this has nothing to do with a video game. But yeah, I had to remember like a whole bunch of mnemonics for things like this one, Dora. Dora stands for DHCP, discover, DHCP, offer, DHCP, request, DHCP, acknowledge. So like these are the sort of things, man. This is the sort of stuff. This is the sort of stuff. Like what else? There's something out there called OSPF. OSPF, EIGRP, IS, RIP, which no one actually uses anymore. BGP, which has 2 forms. Which has many forms, but we're just only gonna mention just the basic stuff. Those things. What else? Oh, one that people watching the channel might actually recognize. Hypervisor. So like type 1 hypervisor, type 2 hypervisor. Like basically you better know how to explain the difference between a type 1 hypervisor and a type 2 hypervisor. Like give multiple, there was so many hypervisor based questions. Like for example, type 1 hypervisor. It's like name a type 1 hypervisor. Okay? The first one that I think of all the time is vSphere and ESXi. And technically, Hyper-V can be type 1 hypervisor. But then it was like, okay, what about a type 2 hypervisor? Type 2 hypervisor, VMware, Workstation. That's like the first one that comes to my mind. So it's like, these are the sort of things, guys. Like, this is exactly why there was no Tech Thursdays. Because it was like, well, okay, we have to learn, like, all of these things, like, over the course of 3 weeks. And it's like, I got it down to the point where I'm like, okay, I'm feeling pretty good. Except, I feel like I don't have enough time. So it's like, I have to basically now cram in the last 48 hours to finalize the preparation for all of this stuff. And then there's like other things too. If I can remember what they are, I'll probably throw them up on the screen. But man, what was it? It's like the hypervisor. Oh yeah. Of course. Oh my goodness, the programming stuff, man. Python. Oh my goodness. JSON. Oh my goodness. XML. Oh, Yang. Oh yeah, the Yang. Everybody needs to know the Yang. Yang. Yeah, Yang. Netconf. RESTconf. Don't forget, also in here, there was REST. Yang, this, that, do. HTTP, you can kind of throw that one in there in the background. And then you have all the, like, security stuff, like a ton of security stuff. Like, DTLS, TLS, IPsec, MACsec, all the different, like, ways to authenticate. OAuth. Explain OAuth. OAuth. MD5. SHA. SHA-512. SHA-256. DAS. Like, my goodness, man. Wow. Are we done yet? It's like, no, there's more. There's more. So it's like, wow. Wow. All the things. All the things. And then there was, don't forget, all the randoms. All the randoms. Because there was a lot of randoms. Like, OMP. Who's going to know what OMP is, man? Like, OMP? Why? Why is OMP here? Like, why? Go away. OMP. Really? OMP? For real? Like, what? Oh, man. All this stuff. I basically had to recall from all the things, from all the years, of all the knowledge, of everything. And then don't forget, oh my goodness, don't forget, northbound, southbound, eastbound, westbound. Oh yeah. Oh no, don't get confused. Don't get confused. Yeah, that was on there too. That was on there. Oh my goodness. The stupid programmer questions though kept messing me up, man. Messing me up. They would give me like this thing of code, like some rando spaghetti code. It was like this random Python spaghetti code, but they like cut out certain parts of the code and it's like, okay, fill in the blanks. And it's like, huh? And it's like, it's this random spaghetti code. It's like like basically define a function. It's like some random function with random parameters. One of the middle parameters missing. Okay, so you're supposed to fill in what that's supposed to be. And then it's like, dictionary, blah, 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 some random values, some strings are in there, and it's like someone puts an array, then there's a list, and then it's like, okay, for line in I, parenthesis, blah, 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 blank, this, then blank, JSON dot blank, open parentheses, blank, comma, blank, blank, and then it's like, print, blank, like, oh my goodness, dude, the coding part, like, what is this coding stuff? I'm not even a coder. This is like programming. What is this? What is this? Oh my goodness, the question, the stupid programming stuff. My goodness, like, who's supposed to know how to do that? Everybody vibe codes nowadays. Like, how are you supposed to know what you're supposed to type in there? You know, what? Like, I'll give you an example. Like, it's like def, and then it's like, str, da-da-da-da, and there's like, blank, comma, blank, blank, this, and then it's like, open, da-da-da-da, blank, comma, W, da, 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 it's like not Jason, JSON dot blank, comma, da, 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 blank. Like, what are we doing here? Like, what? Like, for line in, da, 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 blank. Like, oh my goodness. And you're supposed to figure that out, man. Like, good luck with that. Like, print blank. Like, okay, go fill it in, and there's like just some context of like what it's supposed to be about in general, and it's like, okay, yeah, vibe code that, yeah, okay. And then the part with like, use the northbound API because that's the intent of what we're doing. Okay, and it's like, Yang, use Yang to do the thing because Yang is structuring the data in a simplistic way, but it actually the API call is way more complicated when you look at it in Yang than if you just look at it like in human readable language, or if you just look at it in literally the way like a random network device would look at it. So that test was no joke. Not gonna lie, that is no joke, man. Oh my goodness. Like, it goes all over the place. You gotta know everything from like layer 1 all the way to layer 7. And there's all kinds of stupid things in there like, what happens when the cap wap in the layer 3 roam to the, it's like, what is the layer 2 data plane? Blank. Like, what? It's like, oh my goodness, the cap wap. Like, what is that? Do you understand? I had to go to the bathroom like so badly. It's not even funny. I kind of laugh at it now. It's just like looking back at it. It's like, oh my goodness. Like, what is this? What was this stupid test? Oh man. 100% recommend for anybody who wants to like do a challenge, to take on a challenge. My goodness, certification exams are the real deal, man. Like, what? It's especially something like this. Like I've never seen a certification exam that bounces all over the place. I felt like this is literally like dodgeball. The thing's like bouncing off the walls. It's like, this is what's a type 2 hypervisor. Oh, here, read this spaghetti code and fill in the blanks and fix it. Oh, by the way, build me an underlay fabric for my SD-WAN. It's like, oh, what's a southbound API? Which of the following? It's like, what is the northbound API? Like, what? Like, oh my goodness, are you serious? And then all of a sudden it's like, okay, choose which 2 of the following are part of whatever. And it's like, okay, I just start thinking of the Tekken song when the Tekken song starts playing, when that starts, like the Tekken music, like VBon, vManage, vSmart, vEdge. It's like that starts playing in the background, so I'm like, okay, yeah, I know the answer now because of the Tekken song. So I just had to like vibe through all the questions that I understood because of like experience. But for real, like all this jumping around with like Python and scripting and hypervisor and Linux and so little of it was actually Linux. It was just like, really? Like, I don't know what's going on anymore. But yeah, the Red Hat one, for those of you that have done the Red Hat certification, let me know your opinion on it, because I might actually do that one next. I'm thinking about it. The Red Hat certification, because now that I'm all in on Linux, now we can finally like put all of this to rest, because for real, like this stuff, like, oh my goodness, dude, like this stuff is like hardcore. This is like hard mode. You want to take hard mode? Go do this. Like, this is hard mode. But I hope Red Hat's not like this, because I need a test to be more like confined to a specific skill set. Like this to me seems so over the top, all over the place. Like the scope is so broad. The amount of random things that it's like 1 second you're looking at VMware Workstation, and then all of a sudden now you're like having to vibe code something in real time. It's like, wait, what? So, but definitely really good challenge. Like really good challenge, I will say that. You're preparing for A+, and it is all over the place like what you are describing as well. Yeah, but A+ is definitely more grounded though. This is like A+ will not be talking about like this. A+ doesn't cover this. A+ doesn't cover this. I don't know if A+ does like programming. Does A+ do programming? I don't think so. Does it? Is there scripting on A+? A+ might touch on this sort of thing. And this sort of thing, maybe? It's definitely not going to cover this. I don't think A+ covers any of these things. I don't know if A+ is definitely not going to cover that. Or this. Well, actually, it might. I don't know about that. But I can tell you right now, A+ is definitely not going to cover this. That's not on A+. That's not on A+. That's not on A+. I don't think this is... I don't expect that to be on... Well, maybe some of these are, but I don't know. Most of them... That's... I don't know about that one. This is not on A+. That's definitely not. This might be on N+, but it's not on A+. I don't think A+ covers this stuff. But I don't know, like when I think A+, I think like, okay, let's talk about A+ real quick. What I remember about A+ is stuff like building a computer, basically CPU, RAM, GPU, PSU, redundancy, server architecture, management plane, like basic networking, like in the sense that you're not doing like mental gymnastics of these things, because this stuff is definitely not on A+. It shouldn't be. If it is, there's something wrong with the A+ test. But anyway, like this is what I think of when I think of A+. I mean, you guys can correct me if I'm wrong, but what I remember A+ was building all about computer. All about computer. This is totally not computer. This is like, okay, I guess technically this stuff is, but there's not a lot of computer stuff on there. They have a big security. Oh my goodness. Yeah, security. Oh, yeah, I had to do so much security. Okay, security. I'll tell you the security stuff that you gotta learn. Complete mediation. Separation. Am I spelling correctly? Separation of privilege. Privilege. I can't English today. I'm too tired. Fail safe default. Psychological acceptability. These are the things on A+, I think. Fail-safe defaults. Separation of privilege. Complete mediation. Economy of something. That's what I remember about security. Basically, if you want to work in a cybersecurity, you basically have to know, like, there's more than just these. I'm trying to remember them off the top of my head. Complete mediation, separation of privilege, fail-safe default, psychological acceptability, economy of something, open design, Someone's gonna have to figure out what the rest of them are, because that's my brain is like running out. I'm running on fumes at this point, so it's like that's all I remember. Virtualization and cloud are in there. Given a scenario, apply common methods of securing mobile device. Oh, that. Oh, okay. Yeah. That's actually this. That's what you're talking about. Is this? Yeah, that's this stuff. See, here's the thing though. Like, these things are the core, like, foundational principles of how you can implement security on a hardware device or at large, at scale on a network. That's basically what all of these things are. They all have definitions. They're all basically definitions for security stuff. I had to memorize literally all of them once upon a time. Now, if I can't state them unless I see, like, if I see them, if I read them, I'll recognize parts of the definitions, and that's how I remember which ones refers to what. I remember failsafe defaults is basically like, you don't assume that a device or a user should have privilege, like access to something. You basically assume they should be denied access by default unless explicitly given access. That's like failsafe default. That's like the most basic one. And then there's like all the other ones that are whatever. I can't remember. Economy of what? Economy of... I don't remember. Yeah, zero trust falls into failsafe defaults. So failsafe default is like the fundamental concept. Yeah, those things. Virtualization and cloud. Oh my goodness, virtualization. Wait a minute. Okay, hold on. Virtualization. That's type 1. I had to deal with that today as well. That's type 1 and type 2 hypervisor. Type 1 hypervisor. Type 2 hypervisor. Basically, the way I studied for my exam when it comes to virtualization, I draw a picture in my mind. I basically draw the computer. You have a computer. The computer is like this, and then you have another computer. You have two computers. You have two servers. Basically, you have two Threadripper boxes, or two Epics, or two Intel Xeon boxes. A Type 1 hypervisor runs literally directly on the server. So this is the hypervisor. You literally install the hypervisor directly onto the server. It is also known as bare metal installation. Bare metal, that's the key word. Bare metal implies Type 1 hypervisor. And then when that hypervisor is running, then you can install your virtual machines on top of the hypervisor. These are the virtual machines, the VMs that run on the hypervisor. So you have VMs, virtual machines running on the hypervisor. The hypervisor type 2. Hypervisor type 2. So on the server, you have an OS, an operating system is installed, like Linux or Windows, usually Linux if it's a server. Some kind of operating system gets installed on the server, just like a gaming PC. Then, on top of the operating system, you install a hypervisor. So then you have a hypervisor. On top of that, then you proceed to install the virtual machines. Anyone who has ever messed with VMs while on their Windows desktop or a laptop or on a Linux desktop, guess what? You're running a Type 2 hypervisor, also called like a nested. Well, we won't get into that. That's nested VM. That's basically another concept. But VM running on the hypervisor running on the operating system. This is known as type 1. This is known as type 2. I basically memorized this picture, and I can 100% guarantee that I will get every single question on the exam correct when it comes to virtualization, just from this one picture. Okay, so let's explain. Let's give an example. So basically, a question might show up on the A+ exam, such as, which of the following? Man, okay, clean this up. Hold on, clean this up. Delete all this stuff. Delete this nonsense. The question might be written like, which of the following is a type 2 hypervisor? And it would be like A ESXi, B V sphere, C this is the controversial one, Hyper-V, D VMware workstation. So this is a legit question on an A+ exam for virtualization. And there's only one right answer. And it's like, choose the best answer. It's always choose the best answer, because one of these answer choices is kind of like a controversial answer. In fact, I don't know if I even want to include that one, because that's going to create some confusion. But this is basically the type of questions that you can expect if you're going to take the A+ exam, the virtualization section. So knowing what we know about hypervisors, we can immediately conclude, well, okay, we cannot immediately conclude. If you don't have any experience with hypervisor or with virtualization, then, you know what? I'm thinking of another example. Let's put another let's put another one here, just because I can. Okay, so it's like, which of the following is a type 2 hypervisor? So this is where work experience comes in handy, because if you're familiar with at least some of these and you've installed them before, then it's like, okay, do you know how to install ESXi? Yes or no? Do you know how to install vSphere? Do you know how to install Hyper-V? Do you know how to install VMware Workstation? There are differences. Oh, you know what? VirtualBox would have been a better example than what I put in on answer choice C. But the correct answer for this is D. VMware Workstation is a type 2 hypervisor. This is installed directly on the server. You do not install ESXi on top of Linux or Windows. So this is a type 1 hypervisor. vSphere is also a type 1, installed directly on a server. There's no Windows, there's no Linux. And then Hyper-V is like Microsoft's type 1. Although the weird thing about Hyper-V, see, this is the one where it's kind of like a trick question, because Hyper-V, though it is type 1, it can also kind of like run nested in Windows, making it kind of a type 2. So this is kind of a trick answer choice. But that's the thing about these exams. These exams are always choose the best answer. So it's like, okay, if I know for a fact that VMware Workstation is a Type 2 hypervisor, and I know that Hyper-V can be a Type 2-ish, but it also can be Type 1. If it's both, and if VMware Workstation can only be one, then VMware Workstation is the best answer choice. And BlueStacks is just a VM, you know, that's an Android emulator running on a hypervisor. So that would also be like not exactly what we're looking for. Because the thing is, we're not looking for, the question is asking Type 2 hypervisors. It's not asking for a VM, or it's not asking for a nested VM. You know, it's asking for, like, what is the thing that you can install, and then you can use that tool to install virtual machines on top of that tool. It's not asking about what is the VM, it's asking what is the tool, the underlying tool that the VMs are standing on top of. That is what it's looking for. So the correct answer would be D, VMware Workstation. Anyway, so that's basically my approach when it comes to studying for these type of exams. You basically have to really, truly understand at a very deep level the concepts. Like what they're trying to get across. Like what are these questions all about? But that's a good example, man. Like that's exactly the sort of stuff that I've been having to deal with for the last like 3 to 4 weeks. VMware Workstation. You have VMware Workstation installed? Guess what, man? Guess what? I've got VMware Workstation installed on my Threadripper PC for running virtual machines. And I run a lot of virtualized things on Threadripper. And because people are like, why do you need Threadripper? It's called VMs, man. VMs. Type 2 hypervisor. That's what it's all about. Because here's the thing. Because, like, why am I using a Type 2 hypervisor? Because my operating system on Threadripper is Windows 11, and I install VMware Workstation on top of Windows 11 so I can install my virtual machines on VMware Workstation. That is an example of a Type 2 hypervisor. Basically, anyone who is messing with like hypervisors. So there was a comment earlier about like de novo hypervisor bypass. Well, guess what? That is another example of a Type 2 hypervisor. Because if you're going to run the game on the operating system, you're going to run a hypervisor on top of the operating system to allow you to basically sandbox your game and bypass that. So a lot of people don't deal, so typical people like on their desktops, they're not going to be dealing with Type 1 hypervisors that often. Type 1 hypervisors are definitely in the server world because you're not installing Linux, you're not installing Windows, you're literally installing some sort of like application, in this case a hypervisor, directly on the server, and that hypervisor will allow you to install the virtual machines directly on the server. So that's a Type 1 hypervisor. So yeah, there was plenty of questions on my exam focusing on, I won't say there was plenty, there was a decent amount of questions that I had to deal with today that were about Type 1 and Type 2 hypervisors. In the Type 1 hypervisor, there is no operating system. The hypervisor is the operating system. That's why I said normal people who basically just use their computer normally, they never encounter Type 1 hypervisors. These are examples of Type 1 hypervisors. So if you have no experience with ESXi, if you don't know what ESXi is, if you don't know what vSphere is, or Hyper-V in a Type 1 context, then that's why you don't know what Type 1 hypervisor is. Type 1 hypervisor, like I said, there is no Windows. There is no Linux. There's literally a server with a BIOS, and you install the hypervisor directly on the server. There is no operating system. There is no, like, oh, we're going to go to Windows. That concept doesn't exist on a Type 1 hypervisor. The Type 1 hypervisor provides the operating system that it will use to install and manage the virtual machines directly on top of it. So if you've ever done anything with running VMs on your Windows PC, guess what? You're using a Type 2 hypervisor, not a Type 1. If you're using Type 1, you don't have Windows. You don't have Linux. You had no idea that existed? This is what exists in data centers all over the world. This is used all the time. Type 1. Why? Because it's more efficient. So another question would be, like another question that you could encounter on these type of exams is, what are the benefits of Type 1 hypervisors? A, they have better application performance. B, they run on an OS, on an existing OS. C, Type 1 is, how should I say this? Type 1 run VMs with higher system or like higher, no, Type 1 VMs have higher latency. D, Type 1 VMs use more system resources. So basically, this is a very poorly written question because there's only one obvious real answer here, because I was just literally making up answer choices. This is wrong, and this is wrong. A is the correct answer. They have better application performance. Why? Because they are direct to metal. There's no underlying operating system using system resources. They're directly linked to the hardware. So they're going to get lower latency. The VMs that run, applications/VMs that are running on a Type 1 hypervisor perform better than the same VM running on a Type 2. Why is the Type 2 worse in performance? Obviously because the operating system underneath is utilizing a whole bunch of the physical hardware resources. Think about when you're running Windows 11. Windows 11 is the operating system. Windows 11 is going to consume system RAM, CPU cycles, CPU cores. It's going to use those things for its own use case, like for its own running tasks in the background, literally hosting the hypervisor as an application on top of it. So the VMs are going to perform worse because the underlying operating system is using a bunch of system resources. On a Type 1, this doesn't happen because they literally don't have an underlying operating system using up those resources. On Type 2 performance, yeah, well, again, it's because of the underlying operating system. See, what this type of question is asking is, do you understand the difference that like running on an existing operating system makes versus not having to deal with that operating system at all? That's the difference. That's what the question is testing for. It's checking to see if the candidate knows that a Type 1 hypervisor is superior in terms of performance to a Type 2. Because of the overhead. Yes, there's overhead. Linux doesn't really have anything to do with this. We're not Linux is an operating system. If you're running a VM in a application on Linux, you're running a Type 2 VM because the application that's hosting your VM is the Type 2 hypervisor. Yeah, anything that does not have a, like, user, like, what, you guys understand, right? Like an operating system, when you're using an operating system that's meant for a user to basically use the computer for various different computing tasks, such as checking email or watching YouTube videos or whatever, like, that is what I mean when I say the operating system. Proxmox is not that type of operating system. Proxmox is a hypervisor. I'm not going to be able to go to youtube.com on Proxmox. You know what I'm saying? That's why Proxmox is not an operating system. So, like, okay, there's a difference. Because just because it's, like, Linux-based doesn't automatically make it a full-fledged operating system. Because a hypervisor by itself, a hypervisor is a type of operating system. But a hypervisor is not an operating system in the sense that you're going to like load up your hypervisor and then go use your hypervisor to go watch YouTube videos. Or you're going to use your hypervisor to go and launch like Steam and play games. See, that's because the hypervisor is not designed to do that. Yes, it is a type of operating system, but it is not an operating system that is meant for the user to do like things with the computer that are strictly for the user's benefit, if that makes any sense. So when you run a de novo bypass hypervisor environment is a type 1 rather... No, there is... No, because you can't... No. Guys. Okay, hold on. This de novo bypass thing, if you're running Windows... If Windows, or let's get one thing straight. If you're using, regarding this de novo bypass, because I don't know about this thing, I've not looked into this, but if at anywhere in this process you're running Windows or Linux, meaning you're interfacing with the application through some kind of operating system, that is a Type 2 hypervisor. To be a Type 1 hypervisor, you cannot have Windows at all. You cannot have Linux at all. There is no, like, there's literally no operating system in a Type 1 where you're going to be able to, like, open up Chrome or open up Firefox or, like, go watch a YouTube video or, like, use the hypervisor to go and bypass de novo because the UI is there. No, that is a Type 2 hypervisor. So what you're describing, the de novo bypass, must be a Type 2 hypervisor. If Windows is involved, it is automatically a Type 2 hypervisor. Type 1 hypervisors do not have operating systems in the sense that they do not have an operating system that the user can use to like launch applications. This is why I drew it like this. Basically, this OS is Windows or Linux. It could be Mac, or it could be some other random OS like Chrome, Android, or whatever. But that is a Type 2 hypervisor. You guys understand that now? Hopefully that makes sense. Because the comments about the de novo bypass thing, de novo bypass thing is not Type 1. There's no way it's Type 1. The only way it could be Type 1 is if you're running ESXi. If you guys know what ESXi is, or vSphere, ESXi, these are type 1. If you're using VirtualBox, VMware Workstation, these are type 2. Maybe this helps a lot by giving actual examples. If you use these, you're using type 1. If you use these, you are using type 2. Why? Because these install as applications on top of an existing operating system. These install like you're installing Windows or Linux on a BIOS, on an EFI shell of a motherboard. That's the difference. Type 1 installs on a BIOS. Type 2 installs on an existing operating system. KVM, okay, good. KVM is type 1. Yeah, KVM is an example of type 1. If you're running something off of a KVM, you're not launching something off of Windows, you're not launching something off of Linux, so it's a type 1. Well, it's still the hypervisor, though. It's basically the UI for KVM. It's the manager. It's the orchestration plane, or the management plane for KVM is what it is, in that context. I have Ubuntu inside my Windows that uses... Okay. Oh, that's a great question. Okay. Or that's a great... Okay. Ubuntu running on your key statement, you said on inside Windows. Inside Windows. Okay. Windows. Ooh, Windows. An operating system is running here. Then I'm going to run a hypervisor. And then I'm going to run Ubuntu on top of Windows as a virtual machine. This, what you just described, is an example of a type 2 hypervisor. In this case, WSL can be used to run Ubuntu on top of Windows. Keyword, on top of Windows, or in Windows, on Windows, in Windows. You're describing an operating system. That automatically means type 2 hypervisor. Hopefully the concept's starting to make sense now. Type 1 is also called bare metal. Bare metal. You install the hypervisor directly on the server. No underlying operating system allowed. Like I said, anytime Windows is involved, automatically it's type 2. Anytime Linux is involved, automatically it's type 2. If you're installing this by installing some kind of application, typically VMware Workstation or something similar, or VirtualBox, you're installing a type 2 hypervisor, and then once you launch that application, which is a type 2 hypervisor, you then go proceed to install WSL to launch Ubuntu or whatever, like basically any kind of virtualized machine, VM, or an operating system running on your type 2 hypervisor, like Ubuntu running in WSL or on Windows, All these concepts are all type 2. They're all type 2. All of these things are basically test questions on the exam. Man, I can already tell. I've got mastery of this concept because if I did not master this concept, I would have failed the test. It's that simple. It forced you to run a type 2 hypervisor. Yeah, like I said, most users do not. Most people using their computer are never going to encounter type 1. You either work in industry where your employer like requires you to set something up using a type 1 hypervisor, usually KVM, vSphere, or ESXi. Maybe Hyper-V, but realistically it's those three. And that's pretty much how it's done. Otherwise, you never encounter type 1. Type 1 is more specialized. Type 1 definitely performs better because it's running straight on the hardware. There's no Windows or Linux running in between managing the processes underneath. Because, like, when we... Okay, all the concepts of, like, GPU pass-through. So, okay, let's do some questions here. Let's see if how many people have been paying attention. Because I'm curious to know, like, who actually knows this and who doesn't. Because this is the truth. Let's figure out who knows and who doesn't. Wait, whoops, let's get rid of this question. Let's see. Okay, let's do another question. Which of the following uses GPU pass-through? A, type 1, B, type 2. Let's do this in a poll. All right, the question's up in the YouTube's chat. Which of the following uses GPU pass-through? Only one person voted. Don't be scared, man. People just vote. Just choose something. The question is, which of the following... It's on the screen. Which of the following uses GPU pass-through? Type 1 or type 2? I mean, we're trying to see who here is A+ certified. Or A+ certified capable. Only 3 people voted, man. That's depressing. Either people are scared. I mean, no one's even gonna know what you vote for. It's anonymous. I can't see who votes for what. All I can see is, like, 3 people voted. It's like, I don't know who actually voted. I can see that, okay, 4 people voted. But I'll give you a hint for those who haven't voted yet. There is a key word in the question that actually gives you a hint at what the answer is, based on everything that we said earlier. Man. Okay, that's about a third. A third of the viewers voted, so I guess we'll stop it here. But man, it looks like maybe two people voted, and then 4 people. If it's 6 votes, well, maybe one person voted for the other one. All right, man. All I can say is there is someone out there who voted with conviction. Okay, at 86% to 40%. This is very surprising. 7 votes. We're gonna cap this. I'm gonna cap it. Here we go. The results are in. 86% of you said type 1. 14% of you, which is probably only one person, maybe 2 people, but whoever voted for type 2 is absolutely correct. The correct answer is type 2 hypervisor. That is the correct answer. Type 1 is incorrect because the key word is GPU pass-through. Pass-through. You have to pass the GPU through Windows to allow the hypervisor to let the VM have access to the GPU. The keyword was pass through. Passing through Windows or Linux to allow the virtual machine access to the GPU resources is type 2 based hypervisor. So GPU pass through. This is why if you guys ever watch Wendell from Level 1 Techs and he's talking about like Linux or he's talking about like doing server related things and you hear him talking about GPU pass through, SRIOV, these are all things that always apply to type 2 hypervisors because we're talking about passing through resources. Another example, you want to allow your virtual machine to access the internet. You have to pass through your LAN port on your computer through Windows to the virtual machine. This is another example of type 2. Type 1 doesn't do this because type 1 is bare metal. Type 1 is running directly on the hardware. This is the reason why type 1 has better performance of the VMs. The VMs perform better because there is no operating system overhead. It is direct to metal. The hypervisor is running straight on the metal. So fewer layers in between, causing latency, causing additional resources to be wasted on that underlying operating system. Because think about it, if you're running Windows, Windows is running a GPU driver. The GPU driver is controlling the graphics card. Now, if you want to run Ubuntu on your like Windows, like WSL on a hypervisor to allow you to use your GPU's full potential on Ubuntu running on top of Windows, your system has to pass through the GPU resources to the virtual machine. This is the concept that only applies to type 2 hypervisors. So congratulations to whoever answered type 2, because these are the sort of things when I noticed a lot of people started voting for type 1 and I saw that bar start trending up, I was like, oh no, whoever voted type 2, man, they truly know their stuff. They truly have what it takes to be an A+ certified, because there's peer pressure. When I started seeing that bar on type 1 go up, I'm like, oh man, all those people are getting that thing wrong. They have no idea. Because I said the key word, pass through. You got to pass through your operating system to give the VM the resource, the hardware resource. Type 1 doesn't have to do that. Why? Because type 1 is direct to metal. It is a bare metal hypervisor running straight on the hardware. It's literally the BIOS. It's literally the BIOS followed by the hypervisor followed by the VM. No operating system in between. Anyway, man, these virtualization questions. I had some test questions on my test of virtualization, but I didn't have that many. But this is interesting stuff. Okay. This makes me want to take that Red Hat Linux certification exam now. Because I don't know how much, like Linux is, I don't know, it's going to be like a bunch of like bash shell and ls commands and all that stuff, and sudo this and sudo that. That'll probably be interesting. But yeah. Virtualization is pretty cool. Yeah, Type 2 is a big deal, man. Type 2 is a big deal because a lot of people who mess with VMs on Windows or install VMware Workstation, they have no idea they're using a Type 2 hypervisor most of the time. And I'm not saying one is better than the other. They have their pros and cons. Type 2 is obviously more convenient for like testing stuff because you can literally fire up a Type 2 on your laptop. You can fire it up on your desktop and you can throw the VM on top of that and then just play around with it. So Type 2 has a lot of use cases that are simplistic and convenient. But if you're all about performance of your virtual machines, you're running Type 1. So like, okay, some examples of stuff that would run on Type 1. So I guess what runs on Type 1? So game servers. Game servers are probably, if I had to guess, game servers run on Type 1 for the performance. A game server doesn't need Windows or even like a base Linux OS to run. Like they would run in a VM on a Type 1 hypervisor that would allow them the best performance and give them the best throughput on the network side. So like game servers probably run on Type 1. AI factories are probably running on Type 1 if I had to guess. Although the AI stuff is a little bit, it's newer, so I don't fully know. If I had to guess, it's Type 1 just for the performance. Because I know, like, in the data center world, for AI, latency is, like, the most important metric. It is so critical. So I wouldn't be surprised if they're just running, like, KVM or vSphere, and they're, like, hosting the hypervisor directly on the hardware, and then they've got all their whatever NVIDIA does with, like, the CUDA layer that's running on the application, on the VM itself. So there's all that kind of stuff that's instantiated on top of things, but you don't need Windows for that. You don't need like Linux as an actual OS for that. A lot of these VMs are Linux based, but again, these are VMs. They're not operating systems that will then host VMs. You know what I'm saying? So that's the key. Like if you're running a game server in a data center, you don't need Windows to be running underneath your game server. You know what I'm saying? Like, who does that? Like, why do you need to do that? That just hurts the performance. So that's the sort of thing for Type 1. So you'll only really ever encounter Type 1 if you work in the industry where you actually deal with things in a data center environment. Otherwise, everything that you do with virtual machines as a hobbyist are always going to be Type 2 based hypervisors because you're running them on your desktop. And those are obviously going to be Type 2. There's not much you can do with a Type 1 as a hobbyist unless you literally turned your computer into a Type 1 hypervisor and now you literally have no Windows, you have no Windows. I mean, did I say Windows twice? You have no Windows, you have no Linux, you have no Hackintosh, none of that. It's literally just BIOS, you install this KVM, and you install the virtual machines, and that's the whole computer. There's like nothing else. You can't play solitaire on it. You can't watch YouTube videos on it. I mean, unless you want to install a Windows VM on your Type 1 hypervisor and run Windows on a VM, or I guess Linux on a VM, on a KVM, but like, who does that? It's like, I don't understand. I mean, that'd be an interesting thing to play around with, I guess, but that's something that I would not want to do long term. I don't know how we talked about this stuff for like 90 minutes. I just looked over and I realized, man, I've been live for 90 minutes and I haven't even done anything. Like, I was supposed to stream Saros or Pragmata, and I didn't even get the chance to do either one. I decided, since I'm on Windows, I did fire up this game. I haven't played this game in a while, just to like see what they did with any kind of update to the game. But I haven't played this in a while. This is one of those whatever games like Hogwarts where I just kind of like do stuff in the background while talking to the chat the whole time. Threadripper with a Proxmox install and remote into your Windows. Well, the Windows would be like on a VM, right? Windows would be in a VM though. You wouldn't run. So you're saying you would run Windows on what? On KVM? A Windows VM? Yeah, yeah. You can do that. How many people use Windows in a VM, though? You kind of did that on Azure with Debian. You installed Windows on a VM. I guess... Yeah, I guess I could do that. I just don't know, like, why I would do that and leave it like that for an extended period of time. You know what I'm saying? It's like... Windows on a VM. It's like, what? I don't know. Because then it's like, okay, you want to play games? When I think Windows, now I just think gaming. It's weird that I'm the one who thinks that way when I recently just did a whole bunch of gaming on Linux. I guess it's because of these type of games. You know, these type of games you run on... literally on the OS with no VM on top of it. There was this one game that people in the channel were talking about I think it was last weekend. Somebody mentioned Neverness. This isn't the first time it was mentioned. Neverness to Everness. I might look at that game. I'm avoiding trying to play more of these type of games, though. I'm slowly trying to phase out of playing these gacha games because they're all very repetitive. But that one supposedly has path tracing, which is kind of weird. Like, what? Like, path tracing in a gacha game? Why? You've been playing it with full path tracing? Is it good? Like, is the game good, though? I bet it's, like, no different from this game. It's, like, the same model, the same thing. It starts out, you choose your character, male or female, you go in, you do the tutorial, you do the first area, they introduce this otherworldly villain. I mean, it's just, isn't it, like, the same kind of thing? It's the same, like, I feel like I've been playing, like, too many of these that I already kind of... Like, the previous games basically spoil the new game. I knew that that's what it would take to dethrone Genshin Impact, even though I still think Genshin Impact is still the most successful, at least commercially. I knew that the thing that would dethrone, or not dethrone, that's the wrong word. The game that would basically, like, bring Genshin Impact's popularity down would be other gacha games. Like, other games like Genshin Impact that are newer, that have better visual quality, maybe more player engagement, like more like MMO style. But there are other games that tried to do that in the past, like Tower of Fantasy. Where Winds Meet is another recent one. Where Winds Meet is very similar to Tower of Fantasy, from what I recall. And that game had decent visuals. Where Winds Meet. That was a good one. I don't know. I feel like the gameplay loop on that was a little bit more boring, though, compared to this game. I don't know. Maybe it's just me. My big criticism of this game, though, is this game, it's just too... This game feels like it takes too long to accomplish things. So you just kind of lose interest in it after a while. See, like, I haven't played it in a while, though. So I haven't... It's like when I log in, it's like, oh, there's like a ton of random stuff that I have to just collect. And keep maxing out your resources and whatever. It's like, so, oh, it grew all these plants. That's been there for days, probably, since I haven't played this in a while. I don't even know what I'm supposed to even be growing. I guess this thing? I guess, grow more of these, I guess. It's like planting stuff. Just, I guess, extract another one? So I just -3. I -3 to go... What is that? 3, 6, 9. So you subtract 3 plus 9, so your net growth, your net gain on this is like 6. Yeah, but they still end up being the same type of game, though. That's the thing. At the end of the day, even though the games are different in style, like stylistically they're slightly different, the gameplay loop on all these games are basically the same. I have yet to see a game that's very different. Like, I guess this game is somewhat different from the other popular gacha games, because this one, at least... Like, it has a building, like a crafting building system. Like, you can't... if you like building stuff, you can do that in this game. Like, if you like building up bases, I guess. It has tower defense. Those other games, I think, only have those things as mini games. I don't know. Maybe I'll try that game. But see, like this... See, look at this. If you like Factory Builder... I forgot what the button was to... Was it tab? Okay, yeah. Caps lock, that's so weird. But see, like, if you like building bases, you know, like... It has that as a core aspect. Factory Builder, that's what it's called. Like, if you like building factory simulator type games, you have to understand resource management. You know, see, like, I've got power stations over here. Relay, electrical grid, you know, it's all about AI. So we have like all this automation going on. We're using Ansible scripts to run things in the background as macros. You know, like, it's a very unique thing. It's very controversial, though, because a lot of people who play gacha games don't really want to think too much, if that makes sense. They kind of want to play the game brain dead style. So, whereas I think this sort of play style requires you to pay attention and do stuff, because if you don't build the factory, you don't actually get any good gear. One of the things that's good about this game is you can actually craft gear, which is actually useful. But the thing is, it's a double-edged sword. Like, the good thing about it is you don't have to waste time grinding random, like, dungeons for gear, for drops. Because here, you build your factory, but it's all about building your factory. You build your factory, and then you literally just craft the gear from the factory. So I don't know how it is in those other games, but in Genshin, you literally would spam dungeons constantly for drops. Oh, the Discord, it can be active. It can be active. It's just, I've been really busy recently, you know, as we were talking about earlier. I am, so for those still waiting, I guess the 2 or 3 people that are still interested in the D2, I am still going to work on the overclock for this. I am actually going to do it this weekend. I have not had time to do that. And I know people were asking me about the Intel B70, more like AI benchmarks. That is another thing that is on my list of things I need to do. Now that the test is finally done, now that the certification test is behind me, I finally can do these things that I've been waiting to do for a while. But someone was saying earlier about the FSR4. Yeah, I saw that pop up in my recommended videos about AMD announcing FSR4. You know, I knew that they were going to do that. It's just, it was a question of when, not if. Because the thing that people don't understand, because there's all those people that were like commenting on their recent videos about where's FSR4, where's FSR4 for RDNA 3. They know that they can do that. It's just they had to get it to a point where it's going to be a good user experience so that it's actually worth putting out there. It's not going to have a bunch of weird artifacts. It's not going to have a bunch of weird glitching due to the way that the Int 8 is different from the way that RDNA 4 handles the machine learning upscale. So I knew it was going to happen. I just didn't know when it was going to happen. So I wasn't really that surprised. But I will say something. I was actually very surprised when they announced at the end of that video, they announced, oh, maybe I can just go bring the video up. Let me go find that video. What was that video? AMD FSR 4.1. Yeah, this video. Hold on, let me find it.
As a lifelong...
Oh yeah, here we go. This is the video, guys. Hold on. How do I share again on Windows? Windows. I gotta learn how to use Windows again. Oh, wait, there we go. Okay, Windows.
Gamer, I spent a lot of time thinking about how to push game experience forward across CPUs, GPUs, software, and games. My team and I have been working hard to evolve FSR4 and bring it to...
I knew this was going to happen for RDNA 3 because what a lot of gamers and people, like consumers, don't know is this is something that AMD was being asked to do behind the scenes by developers. So it's not just the gamers. It was developers that were also pushing this from behind the scenes.
More cars.
So I knew they were working on it. I just didn't know when they were going to release it. If I had to guess, I thought they were going to announce it at Computex. I didn't expect them to announce it before Computex, but I thought in like a couple of weeks, Computex, they would announce it for like August or September. So I was quite surprised when they announced this randomly.
We power over 1 billion gaming devices worldwide.
Yeah, see, okay, see, where he says we power over 1 billion... This is basically reference to the fact that a whole bunch of companies, developers, etc., behind the scenes were asking for this. In fact, they were asking for this before the gamers were asking for this. So this is something that they've been working on behind the scenes for a long time.
It's a responsibility we care deeply about. This July,
when I saw this, I was surprised because I thought September. Or like early Q4, late Q3, early Q4. When it said July, I was like, what?
RDNA 3 players will experience FSR upscaling 4.1, delivering sharper visuals and smoother gameplay than ever before. Even without dedicated floating point AI hardware, gamers everywhere
That is a pretty good feat, though, to be able to pull that off with the integer-based.
will be able to enjoy the benefits of machine learning upscaling on their Radeon 7000 series. Gaming is more than entertainment. It is where technology meets artistry. And at AMD, our mission is to give developers and gamers the tools to experience that fully. Bring FSR Upscaling 4.1.
See, all these developers were asking for this for a long time.
The RDNA 3 was an exciting challenge. Our newer architecture, RDNA 4, was designed.
Yeah, see, floating point 8. This is the thing. I knew that in 8 can do it because there's all those people that talk about the modding the driver to be or whatever they do to get it to work
with FP8 AI
with
acceleration, a floating point format that gives the model more.
See, I never bothered to do this because I knew that they were going to do this officially, so I was like, I'm just going to wait until the official thing. But okay, now it's out in the open.
Range to work with and makes machine learning easier. RDNA 3 does not have that specialized hardware, so our teams had to carefully tune.
Notice that they showed the 7900 XTX and how it's a much larger, overall it's a larger chip than the 9070 XT.
Optimize and validate the model for integer-based computation to maintain the high visual quality gamers expect. We optimize memory usage, rework motion vector validation, and reduce artifacts in fast-moving scenes to make sure performance stays smooth. We tested across hundreds of PC configurations in hundreds of games to ensure visuals are sharp and everything works out of the box. Every millisecond mattered because of
this is very good because I feel like this, because of stuff like this, the 7900 XTX is going to go down in history as like one of the best GPUs in terms of how like the amount of long legs that GPU has is insane. Like when it comes to like an AMD GPU that stands the test of time, this FSR 4 thing basically makes the 700 XTX like the best GPU because first of all, the 24 gigs of VRAM from a GPU from 2022, literally a GPU that'll be 4 years old this fall. I just realized that the 7900 XTX will be 4 years old later this year. That is becoming an old graphics card, and that thing has 24 gigabytes of VRAM, which means with all the AI stuff, like the fact that the PyTorch and all those libraries are getting a lot better for AMD for AI workloads now, and that's probably something that needs to be looked at in a future video as well. Yeah, man, the 7900 XTX, that GPU is such a good choice. I got that so long ago, what feels like so long ago now, and it's still so relevant, and this is making it even more relevant again, because I was like, yeah, it doesn't have the FSR 4, but now it has FSR 4 again in a couple of months, so it's like, oh my goodness, we have to bust that thing out again.
It took too long. It would defeat the purpose. The result is FSR Upscaling 4.1 on RDNA 3.
Yeah, man, 700 XTX. I literally have one right there. Wait, yeah, down right there in the Intel Core Ultra. Because you guys remember what I did, right? You guys remember Intel Core Ultra 9 285K. This is paired up with the 7900 XTX for the ultimate gaming experience on Intel. So, yeah, that thing's going to be going FSR 4 in a couple of months.
Bring machine
We're going to be doing some AI stuff with that, because that 24 gigs of VRAM is really nice.
Learning upscaling to more players without compromising quality or performance. I'm grateful to our fans. Your enthusiasm and ideas inspire us to keep pushing games.
Wait, what was that guy holding up? What?
I'm grateful to our fans. Your enthusiasm and ideas
What is he holding up? That's literally a glowing cube. Oblivion... QuakeCon 2004? Where is this at?
inspire us to keep pushing gaming forward. FSR Upscaling 4.1 and RDNA 3 will be ready out of the box for Radeon 7000 series players in over 300 supported games at launch. And for our RDNA 2 players, we have something
okay, this is the part that was the shocker. Like, this, I was not expecting this.
exciting coming early 2027.
When I heard, I was like, wait, what? Wait, I was like, wait, what? What?
FSR upscaling 4.
What? Like, this is the part, this is like the mic drop moment? Because I was like, wait, hold on. I was like, wait a minute, hold on. The 7900 XTX is going to be 4 years old. And is going to get the FSR 4 on a 24 gigabyte RDNA 3. And then he goes and says, hold up, early 2027, RDNA 2 gets FSR 4.1. When I saw that, I was like, wait, hold on, what? What? Like, huh? Wait, hold on, wait, so basically they're saying that my ancient, because how many, that'll be, what is that, 6? 6 years old. 6 years old. 6900 XT will be 6 years old. It'll be in its, yeah, it'll be just over 6 years old when it gets support for FSR 4. A 6-year-old graphics card getting FSR 4.1 with 16 gigs of VRAM. That I was not expecting. This is actually the most shocking, surprising thing that they announced when I saw this video. Like, I was like, wait, what? The RDNA 2 is getting FSR 4.1? How is that even going to work? But man, that's incredible. So that's really good. That's very good, actually. Very good. So, really, really good stuff, man. I'm actually glad that they're doing the RDNA 2. I knew they were doing RDNA 3. I just didn't know they were doing RDNA 2. RDNA 2, I had no idea. Hold up. We didn't do Tech Thursdays, but I do see this. Some GPU news. According to Chinese board channels, NVIDIA is reportedly preparing to increase the price of the GeForce RTX 5090 and the 5090D V2. Looks like Super Googly lucked out in getting that 5090D V2 last year. This will result in a $300 increase for the add-in board partners who purchase these GPUs from NVIDIA. The change follows a significant price increase in GDDR7 memory, which NVIDIA has been absorbing, but now plans to pass it on to its AI. I thought they didn't even sell the chip with the GDDR7 anymore. I thought that they were having to source that separately. The high demand for memory has depleted the supply of GDDR7 across the supply chain. With everything available... Oh no, yeah, I know why. This is happening. I knew this was going to happen. It's all because of the AI. Because I recently learned something. This is what we were supposed to talk about on Tech Thursdays yesterday. GDDR7. The demand for GDDR7 literally went through the roof recently because of AI. Because the companies that are building the AI data centers, the AI factories, are starting to finally be educated on the fact that they don't necessarily need to spend millions and millions, maybe even low billions of dollars on Blackwell 300 with copious amounts of HBM memory. Because finally, they're starting to realize that a lot of people needing to use cloud services for AI only really need AI inferencing, not model training. B300, all that HBM stuff, it's really meant for model training, not inferencing. They're starting to learn, it's about time, that inferencing can be done on GDDR7 without much of a performance loss. So when they found out about that, all of a sudden, everyone's looking for GDDR7 NVIDIA GPUs. In particular, the RTX Pro 6000. The RTX Pro 6000, the demand for the RTX Pro 6000 is shooting up through the roof as we speak. And because of that, people are starting to order hundreds and thousands of RTX Pro 6000s in bulk from NVIDIA and their AIB partners. I don't know who sells. In the US, PNY is the exclusive dealer for the RTX Pro 6000, but in other parts of the world, it's different. That GPU is so in demand now for AI that, and remember, the RTX Pro 6000 has 96 gigabytes of GDDR7, and people are buying hundreds of thousands. They're ordering hundreds of thousands of RTX Pro 6000s. So it's like, I just had somebody the other day, they're basically looking for, they want to basically get, what did they say? They wanted like 50 RTX Pro 6000s. So basically, what does that mean? That's like $9,000. The more you buy, the more you save. However, because of the memory shortage, the more you buy, the more you spend. So now, at the MSRP, that means they have to spend $450,000 on 50 RTX Pro 6000s. And then they also need to get the servers. Like, they literally have to buy the servers. That means they have to buy like well, actually, they're not gonna buy 50. That's it has a multiple of 8. So hold on, let me find the actual number. I think it's like 48, I think, with 2 spares. Yeah, it's like 48 divided by, what is it, 4, I think? Yeah, so they gotta buy like, I can't remember if it was 12 servers or, was it 12? Hold on. 48 divided by 8. It was either 12 or 6. So basically, they have to buy like 6 or 12 servers just so they can house 48 RTX Pro 6000, and then buying 2 spare RTX Pro 6000 just in case like one of them like is defective out of the box or whatever. So that you, like, if you're a company, you never buy hardware without buying redundancy for spares. So if they buy 48, they're buying like 50, you know what I'm saying? Like, they're rounding it up. So yeah. These are the sort of things that are happening literally every single day, man. People are purchasing orders for RTX Pro 6000s literally like every single day, every single hour. Someone in the world, some company somewhere is investing in AI because, like, if you guys have been paying attention, NVIDIA, everywhere NVIDIA goes, they're evangelizing the benefits of AI, why you need to be in while it's cheap. You need to be on the right side of the technology curve, not the wrong side of the technology curve. So they're getting enough people to buy into this idea that they need to have AI either as a service or on-prem. And those that decide to go for on-prem, they're the ones that are purchasing these RTX Pro 6000s. And you can't buy like one. They will not sell you one. If you want to buy one, go buy one at Micro Center or go get one from Newegg. No, they expect you to buy a minimum quantity of like 8, I believe. I think 8, maybe 4 might be the minimum number. It's either 4 or 8. So if you're buying from NVIDIA, you have to buy a minimum order of RTX Pro 6000 through PNY, which is their partner. That's the reseller, or that's actually not the reseller. That's the VAR. Through the VAR is, I believe it's either 4 or 8. You cannot buy less than 4. You absolutely are not allowed. They will not sell you 3. They won't sell you 2. They won't sell you 1. They'll sell you 4 or 8 or more in multiples of either 4 or 8, if I remember correctly. So that's how you buy these if you want to buy from PNY/NVIDIA. PNY is the VAR in the United States. VAR stands for Value Added Reseller. VAR. A lot of YouTube tech channels will refer to them as AIB. Add in board. So, but they're basically the same thing. The difference is the AIB. AIB is typically to intermediate market. So basically to like a Micro Center or somebody. Whereas a VAR sells business to business. So if you deal with a VAR, it's a very different experience than if you're buying through an AIB. If you buy through an AIB, the AIB will never talk to you. AIB, they don't do pre-sales consultancy to a direct to consumer. So if you're buying through an AIB, like if you're buying PNY, AIB, you're going to a Micro Center to buy one, or you're going to a Newegg, or you're buying one through some kind of like retail outlet that interfaces with the consumer. If you're buying through a VAR, you're buying through like a business that's going to sell you direct. They're going to quote you. They're going to expect you to try to negotiate. You're basically going to try to haggle them down, although in this market, with the dominant position that NVIDIA's in because of the whole memory and all this other nonsense, you're not going to have much say in the matter if you're going to try to like bring the price down, unless you want to buy more. That's why he always says, the more you buy, the more you save. The more you buy, the more you save. The more you buy, the more negotiation power you have when it comes to the price. So, but that always goes through a VAR, not an AIB. These are the differences between the two. Like if you're dealing with a VAR, if you're talking to PNY, so like, okay, I'll give you an example. Like if I'm buying, let's say I'm going to start a company, an AI company, and I go on Shark Tank, and Mark Cuban gives me like $5 million to start an AI company. It's like, okay, well then I need to buy some GPUs. I need to go stuff. So it's like, I'm not going to go to Micro Center and buy RTX Pro 6000s. No, I'm going to go to PNY Enterprise or like some company that is a VAR that will sell me the hardware direct. And they're going to quote me. There's going to be an invoice, all this stuff. And I'm going to have like, I want to know like what's their SLAs on like hardware replacements. Because as a regular consumer, if your GPU is defective, you have to ship it to the company and they'll send you the replacement. It's usually a refurbished unit, not a new unit. So if you're going through a VAR, you can pay for advanced replacement. So that means if like your GPU is defective, you don't send it back to them first. No, they send you a replacement in advance, and then you send the defective one back to them. So you don't have that much downtime. That's another benefit of going through a VAR. But again, going through a VAR is completely different. Like you have to have like a registered company. You can't just be some random person like saying, "Hey, I want to buy an RT." No, they're not going to talk to you. They're going to think that you're some like fake news that just kind of showed up like, "Okay, go away, man. I don't want to." Like that's basically how it is. So when is the price crash come? Not anytime soon, I can tell you that. We're in for another wave, man. We're in for another wave. Everything is going crazy right now, especially because of this GDDR7 thing. Now everyone's looking for GDDR7. Everyone's going to look for GDDR7. All the world will wonder after GDDR7. So, it's not going to crash anytime soon. My guess is probably summer, fall of next year is when it'll crash. I don't think it's crashing this year. It will crash, but it's not going to crash this year. Unfortunately for the gamers and the regular people that just want to upgrade their computer, although this year is not a very good year to upgrade, so regardless, it's not a good year, but maybe next year will be better. But yeah, there will probably be a crash summer 2027 or fall 2027, if I had to guess. It's not going to crash this year, no. No. It's only going to go up. Especially with stuff like this. Like, you read about stuff like this, and it's like, okay, well, this right here means for the layman, this literally means it's not going to crash. At least not right now. But I think there will be a change that will happen next year, because next year in the next like 14 months, we'll say 14, where are we, May? About 14 months from now. So July, 14 to 15 months from now, July, August of next year, things are going to start looking a little different for AI infrastructure in particular. Because right now, the big problem is, there's another problem that's looming behind the scenes, which is less talked about, although we have talked about it on Tech Thursdays a few times. The bottleneck right now is not, it's not the inability to get memory chips, although that is kind of acting as a barrier or like a stopgap, or it's like delaying the real problem. The real problem is not actually memory. It's actually power, like electrical power. Like being able to actually turn on and run the servers that have been purchased. Like the electrical grid globally is a problem. And it is a big problem. And I don't see that problem, at least in the US, I don't see that problem being solved in the next 5 years, because it is such a serious bottleneck. So, and there's like, I don't know how it is in other parts of the world, but in the US, like, if a company wants to build a data center, they either got to do it on the down low with the residents in the local area not noticing, but the moment the local people catch wind of some company trying to build a data center in their city or in wherever around their area, they are going to fight it. They're going to protest. They're going to go and complain to the local government. They're going to lobby against it. You know, so you get this battle of like data center AI people versus like regular citizens in the city or the town. And it turns ugly, and it causes further delays. In some cases, it causes litigation. I know of at least 2 or 3 data centers that they're having trouble building because they're literally getting sued left and right by like local farmers or whoever. Or they somehow, you know how lawyers are, man. They can come up with like whatever. It's like, they present some case and now you can't build because you got to go to court and da-da-da-da-da. So it's like stuff like that is another bottleneck when it comes to like slowing down AI infrastructure. Obviously, this is on a smaller scale and it's in isolated instances in different parts of the US. I can't speak for other parts of the world, so I don't know like how easy or challenging it is for a company to come in, buy up a lot of land, buy up a lot, like lock in a bunch of competitive electric utility rates for like 5 years, so that they end up paying way less than the average homeowner in the area, which sounds kind of ridiculous when you think about it. But they're somehow able to negotiate the utility companies to charge them way, way lower than what like the average Joe in their house is having to pay. But obviously those are contracts that expire or go up for renewal. But yeah. Yeah, that kind of stuff. But see, those are the sort of things that can slow down the progress of AI. Those are the sort of things I feel like every time Nvidia hears about stuff like that, they probably just roll their eyes, man. Like, seriously, these people need to get with the program and get out of the way. They're not going to say that out loud, but you know that's what they're thinking. But yeah, stuff like that is... And the thing is, that kind of prolongs the bubble, because if you delay it, it can't pop as fast, because now they're battling these legal cases. So there's all kinds of stuff like that. That's just one example of why AI is in the situation that it's in. Anyway, guys, I think I barely even did anything. I feel like I haven't done anything really in this game, but we talked a lot about like certification hypervisor type topics or whatever it was for like virtualization, which was really interesting. I barely pay attention to the factory stuff in this game. But yeah, those other games, that one game that came out, Neverness to Ever, is it good? Like, is it worth playing? Like, what is its unique thing? You know what I'm saying? Like, is it worth my time playing that game? Or not? Those of you that have played it, let me know. The full path tracing, like, is the path tracing like hardcore? Is it like super hard to run?
Did you see the new Asus ROG Crosshair 2006 board?
Is that supposed to be like a throwback to their original Crosshair from 2006? The very first one that started the ROG brand? I have not seen it. Hey, when is Computex, by the way? That's taking place in Taipei in like a couple of weeks, isn't it? Republic of Gamer. Oh yeah, dude, that looks... Yeah, okay. Yeah, I see it. Yeah, it looks kind of like the original. Except the original didn't have a backplate. Hold on, let me go back to this picture. Yeah, hold on, let me zoom in. Yeah, look at the... Oh, wait. Yeah, man. See, a lot of people don't realize Crosshair was the very first ROG product. This is like a little trivia lesson, or history lesson. The very first Republic of Gamers product was the original ROG Crosshair motherboard. This was the very first Republic of Gamers product from Asus. Yeah. That's definitely a throwback to the old one, the OG that started it all. And the original Crosshair, I believe it ran an AMD 64 Athlon. I don't remember. Was it socket AM2? Hold up, let me see. Socket, was it socket AM2 or socket AM2 Plus? ROG Crosshair 2006. What was the original? What was the actual... Oh wait, what? They actually have the product pages here? I'm actually kind of more interested in reading about the original one. Oh wait, hold on. Do they show the original? Oh, they do show the original one. Do they have tech specs on the original? Because I kind of want to know what the... Was it AM2 or was it AM1? Athlon was my very first PC. Athlon 64. Single core, single thread. The AMD Athlon 64, 3200 plus. Socket 939. This is not socket 939. The original one was, I think, socket AM1 or AM2. I'm trying to find out what it was. Original crosshair socket. Was it AM2? I'm just gonna guess. Yeah, it was AM2, man. AM2 was the very first crosshair. July 2006. AM2. It was a dual-core CPU. It was one of the first dual-cores. Intel, so this would have been like July 2000, that was right before Conroe. Or it was around Conroe. Oh, man, it was during the time of the Great CPU War. Yeah, because this was the time when AMD was better than Intel until this year, actually, 2006. It was 2006. I remember everyone was playing World of Warcraft. Everyone, their dog, their cousin, their brother, all of them were playing World of Warcraft. Their sister, their aunt, their grandma, they're all playing World of Warcraft. And everyone was on Athlon 64. All the like hardcore build your own PC DIY people, the by the way type people, they were all using Athlon 64. Because this is when I got into building computers, was literally the time of World of Warcraft, and the original Crosshair, like the OG Crosshair, was when I started building my first computer, man. My very first computer that I built myself was in 2006. And that was literally, it was literally the summer of 2006. And this ROG Crosshair was July 2006. So, yeah. Wow. What does it do here? Okay. Let's see what it's got. Let me see. Does it have the X8? Does it have dual X8? Dual X8. That's what I'm talking about. Dual X8. 2 PCIe. Okay. When the X16 runs at 5.0 X16, the second one will run at... Oh, they're carrying over the thing from the Dark Hero. Okay. It has that weird Asus ability. It's that Asus exclusive where it can do, like... You can make the second one... You can go in the BIOS and make the second one do, like, 4 lanes of Gen 3. If you want to run, like, a 4K capture card or something. Or a 25 gigabit network card or something like that. Yeah, that's very interesting. So it's got dual Gen 5. It's got 3 Gen 4. So it's got 5 M.2 slots. 2 SATA that can probably do RAID. 2 SATA that cannot do RAID. Okay, so they're doing... 10 gigabit LAN and 5 gig LAN. So dual LAN. One is 10 gig. Wi-Fi 7. Okay. Full Wi-Fi 7. Yeah, that's 320 megahertz. That's a full 6 gigahertz. Okay, it's got all these motherboards have dual USB 4. So it has all the stuff. It basically has all the things that I need. Yeah, this is good. This is good. Nitro path, 10 gig LAN. Yeah, man, the Asus, they're doing the right thing with paying homage to the OG Crosshair. I can tell that that thick heatsink with the metal, literally a copper pipe going through there, on that Gen 5 SSD heatsink, that's going to cool that SSD properly. Unlike the one that was on the original Hero, which is completely inadequate. Does it include the... Oh, wait. Oh, yeah. Wait. 2, 4, 6. So they still only have 6 USB Type A. But they've got 2 more... No, they've got 3 more Type C. All 10 gig. So you can drive triple monitors off the back, off of integrated graphics, if you're not going to use a GPU. I don't know who would use this motherboard without a GPU, though. Full backplate. ROG Crosshair 2006. Oh, man. ROG 2006. I have a feeling we're going to see this shown off at Computex in a few weeks. When is Computex? Computex 2026. June 2nd through June 5th. So that is literally like 2 weeks away. 2 weeks. It's got the button. No more scratching the GPU. It's got the actual button is on there. Okay, yeah, that looks like a good one. In terms of all the, it's got all the right stuff in terms of if you want to run dual, you can run dual GPU. Yeah, dual GPU. The main thing I'm looking for is dual GPU. Or dual Gen 5 GPU, I should say. That way it's dual Gen 5. So Gen 5 at X8, X8. So you can run dual... Yeah, that's good. And then 5 M.2s. 5 M.2s. And none of them use lanes from the PCIe slots. I think. Let me make sure. Actually, hold on. Yeah. Yeah. Yeah, okay. This is good. This is a good one. It's probably going to be expensive, though. It's probably going to be like, I don't know, $800, $750. Is it bad that you want to upgrade? I wouldn't say it's bad. It's just like... That's just how it is when you see new stuff. Is it bad that I got a D2? Like, is it bad that I upgraded or slash side graded to a D2? I mean... We're using the D2 right now to play Ark Knights. Complete overkill. Let me see, what was this computer in here again? Oh yeah, D2. Yeah, D2. We got D2 in here. What else we got in here? We got D2. D2. We got 96 gigs. I feel like every computer that I have has 96 gigs. I feel like I'd never show off a computer that doesn't have 96 gigs. Actually, it either has 96 gigs or 128. I was thinking the other day, like, how many years have I been on 96 gigs of RAM for my average computer? It was either 2023 or 2020. It wasn't 2022. It was 2023. I remember now. So I upgraded. I went from 64 to 96 in 2023. So I've been enjoying 96 gigs of DDR5 for like 3 years. And now, with the situation that everyone's in with the RAM, my goodness. My goodness. My laptop is the same way. The laptop, the framework... Framework 16, man. Linux. Linux is so memory efficient compared to Windows because there's no random like background stuff that's constantly running. Oh, also the battery life. My goodness, the battery life On Linux, I don't know if it's the framework specifically, but the battery life is insane. The battery life is so good. I can't believe it's not as good as Mac, but boy is it good, man. Like Linux has like nothing. When I'm on battery with the framework 16, the fan like literally almost never spins. It literally almost never spins. The computer is idling. I check in terminal using there's like a sudo command. I forgot the command. It's like grep something for the U power or whatever. Dude, this thing on battery pulls like 6 watts. 6 watts on a 16-inch, and that's with the Radeon GPU inside, like with the discrete Radeon 7700S. I didn't even bother to take it out. I could take it out, it'd probably get even better battery life. But like, I can't believe that the world of a difference in terms of the user experience, in terms of using an operating system that doesn't run all these unnecessary processes in the background that just eat up the battery. But on top of that, the memory, like, look at this. I'm using Windows and I'm using 37 gigs of RAM.
Asus is also launching its first ever ROG DDR5 memory modules, 48 gigabytes capacity with ROG mode that switches between 6000 CL26 and 8000 CL36 mode.
See, oh man, thanks for that. That super chat. I would have never known about that if you didn't mention that. That is what I'm talking about, guys. Those of you who have been watching my channel for a while now, you guys know that I typically always recommend either 6000 DDR5 6000 or DDR5 8000. Those are the only two speeds. Now, okay, the only speed in between that I would care about is like 6400. 6200 also is okay, but the problem with 6200 is there are so few memory kits that actually have 6200 as an actual profile that I just kind of like skip over 6200 and I just say 6400. But 6400 is kind of like a weird number. I mean, 6400 is good if you're on Intel, but 6400 on AMD is kind of hit or miss. You can do it. Obviously, I'm doing it right here. You guys can see I'm running 96 gigs, 4 sticks at 6400 mega transfers. But I would say in general, the ease of use in terms of plug and play for 6000 is just kind of a no-brainer. And then if you have a really good motherboard like the ROG Crosshair 2006, you can run DDR5 8000. And the memory module, 48 gig capacity, so that is going to be 2x24, so the total would be 48 gigs. And I've been saying this for a long time. I have this saying, right? Like, what do I say? 48 fast, 96 big. So if you want big memory, you go 96 gigs. If you want fast memory, you go 48 gigs. Why are those the two numbers? Because 48 gigs is the highest, currently, it is the highest capacity that you can get with single rank DIMMs that can allow you to get the best performance for gaming workloads. So this is the reason why, not just that, the other thing is that is the highest capacity that you can run at DDR5 8000. Because you can't do 64 gigs or 96 gigs at 8000. It's just too much for the memory controller. You need clock read driver. You basically need QDIM, and even then, you can't even use. QDIM can't even solve the problem with noise. You have to go to direct to metal. And what's an example of that? Soldered RAM, LPDDR5X. And what's a more recent example of that? LP Cam 2. Cam 2 modules will probably come to desktop in some form or fashion in the future. I would assume, because if we are going to go to DDR6, I would imagine DDR6 is probably going to do away with traditional UDIM form factors and move to more of like a Cam 2 form factor. Just because that's the only way you're going to consistently hit speeds well above 6,000 while also keeping up with the capacity expected. So like when I think of DDR3, you know, I think of 2 gigabytes, 1 gigabytes, 2 gigabytes, 4 gigabytes, 8 gigabytes, 16 gigabytes. Those are the capacities I think of when I think of DDR3. And in some rare examples toward the end of DDR3, I think 32 gigabytes, but that's very, very rare. That was kind of like super high end, or that was some kind of HEDT build. When we talk about DDR4, when I think of DDR4, I think of memory capacities like 16 gigs, 24 gigs. Well, okay, we'll just start with 16 gigs, 32, or 8, 16, 32, 64, 128. But the interesting thing about DDR4 was that you started off with similar capacities to DDR3 on the upper end of DDR3, but you quickly grew to like 64 gigs. Most of the time that I used DDR3, if I think back, I went to DDR4. When I first switched to DDR4, I started with 16 gigs with 2 sticks, so 2x8. Then I doubled up to 32, so I had 4 sticks, 4 times 8. That's 32. And I basically ran 32 gigs from like 2017, 2018, into 2019. Somewhere around the pandemic, I went from 32 gigs to 64 gigs. It was either with the 3800X or the 58. It was probably the 5800X. I can't remember. It was one of those two. I just remember I went to 64 gigs in the DDR4 era, and with the 1x speed Threadripper. Threadripper was DDR4, and I went up to 128. That's right. I went to 128. That's 8 sticks, though. 8 sticks of memory to 128 total on my old Threadripper system, which is the one that's running Ubuntu now. So that was DDR4. DDR5 was unique in that you got these different capacities. A 24 gigabyte DIMM and a 48 gigabyte dual rank DIMM were introduced shortly into the DDR5 lifecycle. So somewhere in like 2023, which was when 24 gig DIMM, 48 gig DIMM. So you could buy like 2x24 for 48 gigs, 2x48 for 96 gigs. And as soon as that happened, almost overnight, I basically immediately swapped over from 32 and 64 to 48 and 96. Because I felt like with DDR5, I learned very early on that you want to be on single rank DIMMs if you care about latency and performance on DDR5, just because of the way the like half bank thing is set up, where it's kind of like one stick is almost like running 2 channels or like a channel and a half, which is very different from DDR4. So because of that, I immediately went to 48 gigs if I'm running 2 sticks, so 2x24. That is my go-to choice and my top recommendation if you want a gaming PC. Like if you're 100% PC focused, or like gaming focused I should say, on PC, you should be looking at 48 gigs as kind of the standard configuration that you want to be on if you care about ultimate performance. Why is 48 gigabytes the magic number? Because it's A, better than 32 gigs. It gives you more capacity than 32 gigs. B, it is also where all the action is at when it comes to the fastest binned kits. C, it is where QDIM kits currently exist. If you're on Arrow Lake or Arrow Lake Refresh, for example, you should be using QDIM memory, and that's going to top out at 48 gigs if you want to actually run at the high speeds. So these are just a few of the reasons why 48 gigabytes is the magic number for a gaming PC in 2026. Now, if you're running 64, you're probably doing that because you didn't know about 48 gigs, which is okay. You have more memory than 48, which is good. It's always good to have more. But you're not going to be running the higher speeds. You're not going to be running the tighter timings. And why are you not able to do this? Because your RAM is dual ranked. It's more dense. It runs hotter more quickly. If you push voltages, it's going to heat up really fast and possibly thermal throttle in the background without you knowing. You'll know, but you'll kind of have an idea because your PC won't feel like it's hard to explain. It's not quite clock stretching, but if your memory is throttling, you'll kind of have subtle hints that your memory is throttling because it's running too hot in the background because the voltage is too high. So unless you're doing active cooling, so meaning you have a fan directly on the memory sticks, I don't really recommend 64 gigs other than like a regular PC that's running Microsoft Excel or something. So that's what I kind of think of like a 64 gig. To me, when I hear 64 gigs, I feel like, oh, that is so 2019. You know, like that feels so 5 years ago, 6 years ago, 7 years ago almost. So, yeah, that's basically the state of where we're at with 64 gigs. At some point, I'm hoping that they'll introduce a single rank 64 gig DIMM. The moment a memory manufacturer is able to do that, I will basically go back to 64 gigs again. Your CPU is having troubles? Who? Crucial had 64 gig per DIMM. No, well, I know there's 64 gig per DIMM. I'm not talking about 64 gig per DIMM. I'm talking about... Wait, actually, what did I mean to say? Okay, hold on. I need to use Paint to illustrate this. Hold on. So, what I mean... I don't mean... Hold on, where's Paint? Oh, I got rid of it. Oh, because I switched over, I have to, like, redo this. We gotta clean all this up. Hold on. It's an interesting discussion on hypervisors. So, okay, currently DDR5 is basically... So you have single rank. So you have well, we won't even bother with 8. There's 16 and 24. DIMM. So that means, that implies 2x16 equals your typical run-of-the-mill 32 gigabyte kit. And then same thing with 24, that's 2x24, so that implies your typical 48 gigabyte kit. So why do I recommend 48? Because it is currently the highest capacity single rank that you can get for DDR5. So what I meant to say earlier was that in the future, hopefully, they'll introduce a 32 gigabyte single rank DIMM that can allow for 64 gigabytes. The moment this happens, I will immediately start recommending 64 gigabyte capacities. But until then, I don't recommend 64 gigs for people who care about performance. Like if they're going for the ultimate memory performance, they should be on 48, not 64. If they care about performance, because 64 capacity currently falls into dual rank realm. of existence. That's going to be 64 GB. And the other one would be 48 GB DIMM, which implies, I don't know why I put 2 spaces there, that just makes it harder to type. This implies 96 gigs. This is the reason why I always tell people 48 fast, 96 big. If you want big RAM, you care about capacity, 96 is the magic number. If you want fast RAM, 48 is the magic number. Not 64, not 32, because those are smaller capacities in their respective realms. Yeah, HUDIM is kind of a meme, man. Like, yeah, that's called regression. That's straight up regression right there. Currently there is actually higher capacity. So there is currently a 64 gig DIMM, so you can get 2x 64. This came out last year. The problem is RAM became so stupidly expensive, and these DIMMs are just so hard to find that I don't recommend them, just because it's like you can't buy them anywhere, and even if you could, they're so stupidly expensive. If you didn't buy them last year, they're off the table. So, ASUS understands this methodology that I'm talking about. So, like, ASUS understands that single rank is the best choice for performance. So, what is currently the highest capacity you can get for single rank? Well, 48 gigabytes is the highest capacity. Until they come out with a 32 gigabyte single rank DIMM, 48 gigabytes will be the go-to choice. If you look at QDIMMs, all of them are 48 gigs. They're all like 2x 24 gig capacities. So that's currently the state of like memory. Although it's all so expensive right now. And the crazy thing is, you look at a 32 gig kit, and then you look at the price of a 48 gig kit. My goodness, the price of a 48 gigabyte kit, it's like night and day difference. I have a hard time understanding why it's so different. It's so incredibly different in terms of the price for a 48 gigabyte kit. Like 48 gigs, if we go look at the 48 gig, what's the lowest price at the micro centers? 400. Okay, but that's like, okay, that's 6400 though. I'm looking for the QDIMMs. See, the QDIMMs are all like way expensive. From Corsair Vengeance, for example. But all my PCs are either 48 or 96. Like, obviously, I don't have 128 because it's like I didn't get this stuff last year, and sure ain't gonna get it now because it's too expensive. So that's the reason why I keep telling people 48 or 96, 48 or 96. Now Strix Halo is 128. I mean, you could get Strix Halo with 64, but personally, I don't see the point of getting Strix Halo with memory less than 128. I feel like, I guess for like a handheld gaming device, Strix Halo at the 32 gig would be interesting. The 64 gig variant would be good for maybe a gaming laptop or some kind of laptop. But the 128 is really where it's at. So anyway, hopefully this info was somewhat useful to you guys if you're interested in getting memory this year. But buying memory this year is just not something to do, to be honest. Like, it's just not a good time to buy memory. But I'm thankful that you entered that super chat about the 6,000 and 8,000 modes. That's really good. That shows that ASUS is on point in understanding that 6,000, 8,000 are actually the really good modes, or the really good speeds, I should say. So, I mean, you know, like we've talked about this on Tech Thursdays multiple times, but 6,000. So 6,000 mega transfers implies what? It implies the MCLK equals 3,000 megahertz, right? So that's 3,000 megahertz. That's 3 gigahertz on the RAM. That's very fast. That's very fast RAM. The UCLK in a 1-to-1 can also run at 3,000 megahertz. It doesn't have to, but it can. And this is kind of the limit of what it can do. And then you have FCLK. FCLK is typically running at 2,000 megahertz. And there isn't really any reason to run this higher. So the cool thing about this is the memory controller and the memory itself run at the same speed. But this doesn't actually benefit you as much as if your FCLK and your UCLK were synchronized. This is the reason why 8,000 is also a very, very interesting number. Because at 8,000, DDR5 8,000, MCLK equals 4,000 megahertz. UCLK equals 2,000 megahertz. And FCLK is 2,000 megahertz. So that means at 8,000 we achieve true synchronization. Here, FCLK equals UCLK implies synchronization. Synchronization occurs. So now, what does that mean? Lower. This is called inherent reduction in latency. So you automatically get lower latency when you do this because you don't have to buffer. The buffer between the two of these doesn't have to fill the buffer. There's no queuing that's happening. So as a result, you get lower latency. This is a benefit. This is a system level benefit overall. That is the reason why 8,000 is a big, big deal on a Ryzen based platform. 6,000, okay, 6,000. People are gonna be like, oh, well, how come everyone always talks about this? Okay, yeah, that's good and all. But let me tell you something. MCLK equal UCLK is not as beneficial as UCLK equals FCLK. UCLK equals FCLK is almost always better than MCLK equals UCLK. For one thing, it results in natural lower latency through the IO die. Because when you have the cores, the CCDs, you have the CCDs sending the data through the fabric, then that has to send to some kind of buffer. There's a buffer device. I forget what it's called. It's a synchronizer. And then that goes to the UCLK. And the UCLK goes to the RAM sticks. The RAM sticks. And then it comes back. And then it goes back. And then it goes back. And then it goes back. So in here, I guess I should have drawn this larger. This is FCLK. FCLK is right here. Then you have buffer. You have buffer in the middle. Then you have UCLK. Probably should... Oh, I should have drawn this differently. I'm in the way. Wonderful. Let me move myself out of the way while I'm in the way here. Okay. So, then you have UCLK. So why is... Whatever, just put this like here, I guess. So, when you run your RAM at 6,000, these two are not equal. They're not equal. 2000 does not equal 3000. So what happens? The buffer activates. So you have to queue up the data. The fabric is still a lot of bandwidth. The fabric processes a ton of bandwidth. But the buffer has to buffer the traffic from the UCLK because the UCLK is running at 3 gigahertz versus 2 gigahertz on FCLK. So there is an offset in the clock cycles between the two of them. So the buffer has to synchronize the data for transport between FCLK and UCLK. So this results in a latency penalty. Latency penalty inside the I/O die of the Ryzen CPU. This is running at DDR5 6000. Now, the MCLK is over here. I forgot to point that out. MCLK is over here. So the signal from the UCLK, it has to traverse the long distance across the motherboard traces through the memory sticks. It's driving that long road. It's on the long road. And then it gets to the MCLK. Then it drives into the driveway. And then it has to park. And get the data. Load or write from the RAM. The load and the write is the slowest operation in this whole chain of events. And then finally it gets the data. Then it travels back on the long road back to the CPU. So you can see, what does that mean? That means that the faster we can make MCLK, the better the performance will be. And the closer we can get FCLK and UCLK to synchronize to the same speed, the lower the latency within the fabric we can get. This is the reason why 8000 is better than 6000. Because 8000, unlike 6000, speeds up the slowest component in the entire system, and that is the actual RAM itself. The RAM is the slowest component. So if you can increase your bandwidth while also trying to keep your latency on your RAM timings as tight as possible, you will get the absolute best performance that can be offered by DDR5. And if you can get your FCLK and your UCLK to be equal, ideally equal to each other, which naturally happens when you're running at 8000, it magically happens at 8000. Something magical happens. FCLK and UCLK are the same exact speed. That means if I send data from point A to point B, and the two of them are synchronized in terms of the frequency, that means every clock cycle, they pass the data transparently to each other. Not transparently, but they pass the data to each other on a single clock cycle. They're in lockstep with one another. That means the buffer doesn't actually have to do as much work, ultimately leading to an inherent reduction in latency. This is reduction in natural latency of the computer system at an architectural level. This is one of the key advantages of DDR5 8000, specifically on a Ryzen platform, because the magical synchronization between the fabric and the memory controller occurs, resulting in a natural reduction in latency. You don't even have to do anything within the BIOS. You literally load the 8000 profile and it just magically happens. The one caveat is that F clock needs to be running at 2 gigahertz, which is what it normally runs at anyway. So that is the reason why. For an ultimate gaming setup, I would go DDR5 8000, 48 gigs. And if I care about capacity for like a workstation, editing station, I go 96 gigs at like 6000. Because that's going to be the capacity. This is going to be the upper bound on the capacity. This is the upper bound on the speed. But this is more than just the upper bound on the speed. This is also a magical thing that just happens with the CPU. If you go beyond 8000, it's worse. It results in worse performance. Because 84 mega transfers implies what? It implies 42, it basically means MCLK equals 4200 megahertz. UCLK equals, this would be, what is this, half of this? So this is 2100 megahertz, yeah. And then FCLK is still 2000 megahertz. So at this point, now you no longer have these two in lockstep with one another. So you basically are back to buffering. And yeah, the RAM is running a little bit faster. By going from 8000 to 8400, you gain 200 megahertz on the RAM, but you've now basically reintroduced some form of latency, even though it's small, into the subsystem there. So this is the reason why I don't recommend anything above 8000, nor do I recommend anything below 8000. 7800 would be terrible. 7800 would also be a garbage number. 7600 would be bad. 6600 is bad. 6800 is bad. So like all these numbers are basically bad. And luckily, ASUS recognizes these concepts. That's the reason why they have that memory kit, because they understand exactly what I just said. They can see this internally with oscilloscopes, looking at the RAM, hook it up, direct current. They can see all of it. So, and they can also measure all of it too. So this is why 6000, 96, 8000, 48. Nothing else really matters. At least not with Zen 4 or Zen 5. Anyway, guys, that's probably going to be doing it. That's going to do it for this stream. I'm really tired. Yeah, I've been live for 3 hours. So that's a good amount. But I wanted to at least do some kind of live stream engagement with the audience, because I did cancel Tech Thursdays yesterday because of all the crazy stuff that I had going on this week. But luckily that's all done now. So we will be able to get back to regularly scheduled programming. So we will be back next week with Tech Thursdays, and then I'll be also working on the overclocking video that I've been meaning to put out for the D2 that I have here. So the 9950 X3D2. So stay tuned for that, for the few people that are interested in it still. But anyway, guys, that's gonna be it for this. I don't even know what we did. We talked about hypervisors for like 90 minutes, and then somehow ended up talking about RAM and a motherboard. But anyway, guys, thanks for supporting the channel as always, and I will see you guys next time. If you have tech-related questions, feel free to ask them. I just have to end the stream now because it's just like I haven't slept. I need to sleep. I got like 3 hours of sleep, and I'm about to like fall asleep. So thanks for tuning in, guys. I'll see you next time. Take care.